If you think working with dates is easy, you've not bumped up against the complexity involved. There's a lot they don't teach you about working with date times in your undergrad degree, and I'd venture to say that all assignments are probably in the one time zone. This video and future ones will address the complexity of dates, the kind of things I've learned on the job as a working developer. Specifically, today we're going to look at ticks and milliseconds, how they are different and what they represent. I'd like to start our journey with dates with this Stack Overflow question, which highlights a really interesting and important concept. So the person has asked, I've got a date time now, I'm converting that to universal time, UTC, and they're not equal. Why aren't they equal? Well, there's a couple of concepts here. Firstly, when you're dealing with dates in different time zones, etc., there's a concept of an instant in time. So now where I am in a time zone of +10, it's the exact same instant in time as UTC, which is technically not a time zone, it's a time standard, but let's just use it synonymously with the concept of time zone, and it has an offset of 0. It's the exact same instant in time, now here is now there. However, the representation of the date and time is different. Whilst it's 2 p.m. in the afternoon here, it's 4 a.m. in the morning in UTC. And so the reason that this person has come a cropper is because two dates in .NET are equal when they have the same number of ticks. And to understand what a tick is, we'll be able to understand how the API works, and so we're going to examine that next. I've got a little application here which helps me with converting dates from different time zones to other dates and times. So if I select Brisbane from the drop-down box, which is where I'm currently at, and do a convert, you can see here we've got 2 p.m. in the afternoon is equivalent to midnight. So midnight on the year 2000, 1st of January, is 2 p.m. on 31st of December 1999. And if we look at the ticks are different. That's because they're different times. It's midnight versus 2 o'clock, and that's what's happened down here in the Stack Overflow. If you could think of date time now there as that midnight, and then the 2 universal time as the 2 p.m., that's why the ticks are different. Ticks are basically concerned with the actual representation in time instead of the instant in time. And that's how ticks work. If you go and look at milliseconds, you'll notice that the milliseconds don't change. And that's a bit of a clue as to why milliseconds might be something to do with an instant in time. So if we now look at this diagram, let's just look at the definition. The value of this property, ticks, represents the number of 100 nanosecond intervals that have elapsed since midnight, January 1, 0001. If you read the documentation further, what that actually says is that the two starting points are different. So it depends what time zone you're in as to when 1 January 0001 is. And that in +10 is different to that in the UTC time zone. And that's why the ticks are the exact same depending on which time zone you're in, because the starting point and ending point is different, but the actual duration, the number of those 100 nanoseconds, is the same. I can demonstrate this in code. You can see I've got two dates here, one of them UTC, the other one local. They're the same representation of date, being 1 January 2000, but in different time zones. And when I run that, you can see the ticks are the exact same. Now, if I change this bottom one to universal, like that person and the Stack Overflow question, you see now the ticks are different. And I'm now just going to put a breakpoint here and run that. And when it hits the breakpoint, you can see that it's actually now 1999. So we now have a new date time which has been returned by that to universal, and it has changed the representation of the date and time to 31 December 1999. Dovetailing back to our original Stack Overflow question, it's the same instant in time, but when we call to universal on that local date time, which was 1 January 2000, we see it gets converted to a representation of date and time of 31 December 1999 at 2 o'clock in the afternoon. So the next thing I am going to look at is the concept of milliseconds, which we saw in that tool. And that's when we need to start to turn to the DateTime offset struct rather than relying on the DateTime struct. So going off on a little bit of a tangent here, I've got this application I was using earlier, the temporal conversion machine. And on this tab, I've got these milliseconds. So let's go and take that and we'll go to this website, the epochconverter.com, and plug that in here and click the button, and you can see it's giving us those same dates from the application I was using before. So previously I used to use this website all the time as a web developer because on the applications that I worked on, the JavaScript sent this value here, the milliseconds, to the server. And the reason for that is it was an exact instrumented instant in time. It wasn't a representation of time, it was an instant in time. And the instant that it represents is the number of seconds since the UNIX epoch, that being midnight on the 1st of January of 1970. And so if we look here, I can now just plug this into the first tab and convert that. I need to select Brisbane, my time zone, and then convert. And you can see it does the same thing as that website. But I did want to show you that website because the epochconverter.com was a very useful website for web developers. I just have happened to render it nugatory with that tool I created. Let's now take a look at some code to demonstrate some of the concepts we've been talking about. We've got these two date times here. Both of them are the same moment of time. But they're different representations in time. So we got 2 o'clock in the afternoon on 31st of 12th and midnight on the 1st of the 1st. I've removed the DateTime kind structs at the end there because I no longer really need to specify that anymore. And they're not really very helpful. And they're actually something which I should do another video on because they are helpful in a different context, just not here. And so we've got the DateTime offset, you can see below that. Now, this is what you need to deal with when you're dealing with instants in time, because when you're dealing with the DateTime offset, it has a concept of an offset and it is able to compensate and determine the exact instant in time. And what we have here, we're passing in firstly the UTC version, so the 2 o'clock in the afternoon version to that first one, and we're calling that UTC. And I'm also giving that an offset of 0 because the offset for UTC time standard is 0, and that's somewhere over near the Greenwich, London area of the world. And the second one is for Brisbane, which is my offset, which is 10. And so I've created a DateTime offset called Brisbane there. And I'm calling a method called to UNIX time milliseconds on both of those to get these two epochs. And if you look at that, they are identical, which is what we expected, the same instant in time. And they are the same instant in time. 2 o'clock in the afternoon on the 31st of the 12th was the same as midnight on the 1st. So we can visualize that on this slide here about the Linux epoch. I've got these two timelines. One is in the UTC and one is on my time zone offset of 10 hours plus 10. And I've put 1 January there at the beginning of the plus 10, but the time then actually would have been 10 a.m. in the morning. And so if I go to the end here, we've got 1 January 2000, which is equivalent to 31 December 1999 at 2 o'clock in the afternoon. But notice the milliseconds are the same. And that's why it's an instant in time. And those milliseconds are the number that have ticked by since 1970, the 1st of the 1st. And as I mentioned before, that's known as the Linux epoch. So let's summarize what we've gone through here. When we're talking about milliseconds, the one value will be the same instance in time, whether it's 31 December 1999 at 2 o'clock in the afternoon in London or midnight on the 1st January 2000 in Brisbane. Different sides of the world, but the exact same moment in time, and that's the milliseconds since the Linux epoch. When we're talking about ticks, one value will actually be two different instances in time, but they're the same time in terms of the representation of that time. So it's the 1st January the year 2000 at midnight in both places, London and Brisbane, regardless of the fact that that is actually 10 hours apart in terms of the instance in time. And that kind of makes sense when you think about it, because equality of date times, as per the documentation, is measured in ticks, and date times have no concept of an offset. Once you need an offset or start looking at an offset, then you're looking at a completely different struct known as the DateTime offset. Hopefully you found this video interesting and helpful. What I want to do in the outro is just take another quick look at that little application which I built, and the source code for that's on GitHub. A link to that I'll put in the description of this video below. And so previously, as I mentioned earlier, I used to go to this website, Epoch Converter, to do my conversions from milliseconds. But with this tool, I can take that and plug that into this first tab, and voila. Obviously, that'll be the same because I've got UCT selected in the drop-down box. But if I choose another time zone, it does a conversion for me, and that's a conversion to UTC and the relevant one. Now I've got this other website which is tick centric, and so I can take the ticks for that time and go to the last tab, plug that in there, convert, and that gives me the date and time. Notice I do not have any concept of an offset there, because that's all the date time is, date and time with no concept of an offset. We've seen the second tab, and that's just basically a tab of local time and UTC, so you just click the time zone. But this third tab is the really interesting one. This allows you to convert between two different time zones. So Fiji and say Dhaka, and so I'll do the conversion there, and the target time zone is Dhaka. Fiji is in the text boxes up the top. And as I said, that's particularly useful because generally with .NET and the way date times work on your PC, there's only a concept of local time zone, and UTC doesn't really contemplate a third time zone. So that tool actually allows you to convert between two time zones, neither of which are the local time zone of your PC. As I said, if you found this video useful, please subscribe and click the like. Thank you.